It tells us Jake's utility function, and it tells us some different gambles he has. He has a scenario 1 gamble and a scenario 2 gamble. It says that there are no differences in administrative and transaction costs between scenario 1 and 2, so everything else is held equal besides the differences in the gamble itself. And the question says, expected monetary losses in scenario 1 are blank. Well, we know that expected losses is equal to our initial wealth minus our expected wealth. So for scenario 1, our expected wealth is the 20% chance we lose 40 and end up with 60, plus the 20% chance we lose 80 and end up with 20, plus the 60% chance we don't lose anything and end up with 100. So we solve that and we find that $76 is our expected wealth. Therefore, our expected losses is $100, what we start out with, minus what we expect to end up with, 76 or $24. The next question says, the certainty equivalent of Jake's lottery in scenario 2 is blank. So now we're looking at scenario 2's gamble. Well, his utility function is 1 minus 10 over W, and scenario 2 says there's a 40% chance of losing 40 and a 10% chance of losing 80. So that means there's a 50% chance of losing 0. Well, we can plug that in. Every state we want to plug in the utility function because the certainty equivalent is all about how he feels about this gamble. So we need to bring in the utility function. So 1 minus 10 over the certainty equivalent is equal to the 40% chance we end up with 60, the 10% chance we end up with 20, and the 50% chance we end up with 100. This is a lot of math from here. We're just going to work that out. We find that 1 minus 10 over the certainty equivalent is equal, once we add all those up, to 0.8333 repeating. So we can subtract 0.8333 from each side and add 10 over the certainty equivalent to each side. So I've just simplified this to 0.166 repeating is equal to 10 over the certainty equivalent. Cross multiply by each side and divide through by 0.166 repeating, and I get the certainty equivalent is equal to 60. The last question says, which of the following is true? So we're looking for the true statement out of all these different statements. Well, first let's look at A. It says the value of insurance is higher in scenario 1 because there is an equally higher chance of both of the extreme outcomes, no loss or a large loss. Well, this is true, and I'll explain this a little more, but first let's look at why B, C, and D are false. It says the value is the same in 1 as it is in 2 because the utility function can be renormalized. That just doesn't make sense. The value of insurance is definitely not the same if we have different gambles going on. C says the value of insurance is higher in scenario 2 because there is less chance of incurring no losses. Well, that also goes against what we know. If there's less chance of no losses, that's one of the extreme outcomes, no losses. It seems like the value of insurance wouldn't be more valuable there. And D says the value is the same in 1 and 2 for any expected utility function. Well, we know that it's not the same. We can get rid of those. Let's take a look at why A was correct. Well, here was our two gambles, scenario 1 and scenario 2. And we see that both of the extreme outcomes, which is either losing $80 or losing $0, option 1, scenario 1, has a higher chance of each of those extreme outcomes. So what that's saying is option 1 is riskier because a riskier gamble has you have a less idea of knowing where you're going to end up. And option 1, you have a higher chance of each extreme outcome. So anytime you have a higher chance of the extreme outcomes, that gamble is riskier. So a riskier gamble, we can assume that insurance is going to be of more value. So the value of insurance is higher for a riskier gamble, which in this case was scenario 1.